Hello, beautiful people. Future me. Welcome to another programming workout of mine. So let's do 5 minutes of typing, shall we? Does it someone even watch this? Probably not. But who cares? Oh wow. Alright. 3%, that's good. That's good. Just keep it going, keep it going. I felt I felt good about this run. We have a few seconds. Okay, we are out of the time. That means we will be doing some, well, today SQL. So I'll stop this clock, go here, and we will start in the next thing. 25 minutes I have for it. So what do we have? We have a table users, ID, name, discount ID is the foreign key. Then we have discounts. So this is discount is not now. This could be now. I'm registered with discount. Sure, but with no discount. Okay, now then we select that, and that is a left join. So we will get everything from users and something from the discounts. Okay. So first we have a name that will be Amir in here. Amir. Then we will have this count code, and that will be 3 1. Okay, and the second one will be name, and that will be Betty. And the discount code will be null because we don't have anything, and they're matching the Betty. So that's correct. User join to get a list of usernames and comment text for every comment in the system. Make it a left join, so that also includes users who have never written a comment. Select only name and comment text columns. Okay, so we will select and that will be okay. So we want comment text and name, so let's select comments dot comment text. Then we will select users, I think, yeah, dot name. Now you'll steal it from users. Oh, we want all users or all comments? Select and includes users who have never written a comment. So the users will be that one. Then left join comments where, and that will be users dot id equals what? User ID comments at user ID, like this. I think that's good. It's not. I did not want it to read it. Okay, so this is okay. This is comment text. Stronger dislikes water name. Amir. Okay, so what is the difference? Maybe typo somewhere. Comment text. This fluff needs bad. Name Amir. Mama and the text. It says fluff strongly dislikes water dot comma name Amir. Oh, and we have here extra, and that is context now name Betty. Why it did not work? I don't understand it. We've got the two comments from Amir. I don't get it. I don't get why it did not took all of the users. Okay, so I'll try to switch users and comments, but I don't get it. I, the previous version looks correct to me. I don't know. I don't know. Let's just continue. Join mistakes. Well, I did some, so let's see. Let's examine some subtle mistakes on that we might make with SQL joins. First, what happens if we forget to add on condition to an I said where, not on. So that's the mistake I think I did. With no on, and inner join returns every combination of the left table rows with the right table rows. In the left table has n rows and the right table has m rows. Will be n. However, we won't notice that mistake if we only test with simple cases. For example, imagine that we are joining users with their comments, but we forget the on. If we only test with one user and one comment, then the results will look correct. So this is users, that one, Amir, comment. Okay, test, select. So let's put the name, Amir, and comment text. I will say as fluff needs that this. We can close that. The on is missing. The on is missing, but our tester doesn't know this. There is a great rule of thumb in testing. It goes like this: if you are testing code that deals with arrays, write separate tests for 0, 1, and many elements. We can imagine similar process for testing joins. When joining tables, it's a good idea to test multiple cases, like uh, uh, like no rows on the left table, on the right table, both have multiple rows. Okay. Sometimes you'll want to add even more cases. What happens if the left table has multiple rows that match one row on the right, etc. As usual, the amount of testing should match your confidence in the code. Testing is deep and subtle, but there's a baseline rule that you should always use when writing a join. Never test a join by inserting only one row into each table. That test is two do's like the one above. Almost any join will pass it, even if it's wrong join. That rule will catch other mistakes as well. For example, what happens if we accidentally flip the order of the tables with in a left join? In the next example, we meant to select users left join comment, however, we mixed up blah 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 comments left join users. It's common to mix up different join types, so this is a realistic mistake. We only test the join with one user and one comment. It could be a left join, a right join, or inner join, or an outer join. They are all the same. For the test case, but only one is correct. So you have a users comment, then Amir has a comment. Okay, sure. Join. Okay, so we will have results name Amir, and then we will comment text, and that will be sys of names bad. Okay, one final type of join mistake. So far, all of our examples have used foreign keys and on. Usually, that's a good idea. Joining on foreign keys means that we don't have to worry about cases where the join condition column has a value but it doesn't match any value in the other table. However, the database will let us write any on that we want. It doesn't care whether there's foreign key or not. For example, it will let us join against the wrong table's ID. Be careful with this example. It will successfully produce one joined row of user with comment, but the user's name will be Mrs. Fluff, not Amir. So users get comments, and then we will do insert cat, insert Amir, insert into comment, then blah blah blah, select name from cats join comments. Okay, so this one I believe will be his name, and okay, so name will be sys fluff, and then we have a comment text, and that will be and this will be Mrs. Fluff. It's bad. We can tell that this is wrong because no cat who has ever existed would say that they need a path. Like our previous examples, more thorough testing will highlight this kind of mistake. There's another method to spot it as well. In past lessons, we've recommended listing the columns in a select on separate lines, like we did in this example for joins. We've also recommended explicitly naming those columns tables like select user.name. However, we intentionally didn't follow that advice above. We selected only the names of the columns without specifying which tables they came from. Qualifying the column names with their tables makes it easier to spot this kind of mistake. In order for this mistake to happen, we'd have to write select cats.name, just seeking the table name a second time give us a chance to notice the mistake. Hopefully, we type the correct table name, the second name uses that name. If we do that while selecting from a join that doesn't include users, we'll get an error. You can type error to indicate error. Select users.name cats. Okay, so this is just error. SQL is quite good at preventing mistakes. That's what all of its constraint types are for. However, it can't save us from every mistake. Hopefully, this lesson helps you to catch some mistakes earlier. We can reduce the advice here into two minimal rules. When testing a join, use more than one row in each table. When testing from a join, qualify your selects with table names, like select user.name, to make sure that you are selecting the right things. Okay. On versus where. For this lesson, our goal is find the pairs of cats and owners where the person's name is the same as the cat's name. All of the examples in this lesson will use this database, but it will always be empty at the beginning. So people, cats. Now we are inserting something. So we have a Wilford, and the cat has a Cindy. No, Cindy has no cats. Okay, so that will return us just that. Oh, insert into people. Yeah. First, we'll do the query in a straightforward way using both on and where we use the on to match people and cats using the owner ID foreign key. We use the where to select only the person cat pairs where the owner's name is the same as the cat's name. Note the S column aliases. So we'll get person name and get. Okay, so this will be Wilford. Then we will have a cat name, and that will be also Wilford. Close this. So we have a on, and on that we have where. I see. Okay. If we like, we can move the people.name equals cat's name check into the on, eliminating the where. On gets on and people name. Oh, nice. So person name Ford cat name Ford. Ah, I see person name. That's not correct. So the cat's name isn't a foreign key to the person's name, but that's okay. You can still compare those columns in the on databases. Don't limit what we put in on. But we are right now limited by our time. We are a few seconds over, and that means we are done. And done is better than perfect. We finish this one, and I'll see you next time. Bye.